So we've looked at the theory behind using inverse trig functions. What we're going to do here, I'm going to give you a couple of examples. I want you to read the examples, pause the video, work them through, and then come back and check your answer with the working I'm going to present to you. Here you go. So I've got three integrals I want you to calculate. First one, second one, third one. Difference between the first two and the third, obviously, is this definite integral with limits. So pause the video and have a crack at them. So the first one, integral of 1 over 25 minus x squared dx. Now remember, the integral of dx over square root of a squared minus x squared, that has a standard integral form, sine minus 1 of x over a. And then plus a c, my constant of integration, obviously when it's not a definite integral. So what we're able to do here is just use this format, figure out the a from that, and then plug it in together. Well, matching them up, I can say that a squared is 25, so a is 5. So quite simply, for this one, I can say the integral of 1 over square root of 25 minus x squared dx, that's equal to sine minus 1 of x over 5 plus c, plus my constant of integration there. So a nice straightforward one to do to begin with. Again, it's just remembering this standard format here and my substitution. The second question was the integral of 1 over square root of 3 minus 4x squared dx. Now again, we have to remember that integral, 1 over square root of a squared minus x squared dx equals sine minus 1 of x over a plus my c. Now the only difference here is I've got a constant in front of my x squared. First thing we have to do is get rid of that, then we can use this here. The only difference then will be I have some coefficient of sine minus 1, but that's determined by me removing that constant. So if I just focus on the denominator here, square root of 3 minus 4x squared. So to get rid of that, what I'm going to do is take 4 out as a common factor from both terms. So I'm going to square root of 4 bracket, well, I have to take into account I've taken a 4 out as a common factor here, and make that 3 over 4 minus x squared. Now, if I multiply this whole bracket through by 4, I'll end up back where I started, so this is the right first step. I can then split this up and I'd have root 4 times the square root of this, root 4 is 2, so I'd have 2 times the square root of 3 over 4 minus x squared. Now this can be equated to this in that same format. So what I can do is make my integral, the integral from 1 over 2 square root of 3 over 4 minus x squared dx. Now this 1 over 2 here, which I can split off, becomes a constant in front of my integration. So I'd end up with 1 over 2 times the integral of dx over square root of 3 over 4 minus x squared. So now I just have to equate, find my a from that, and I can use my standard form. So equating them both together, I get that a squared equals 3 over 4. So a is equal to the square root of 3 over 4, which is equal to root 3 over 2. Never said you can't have a fraction for a. Never said that at all, or end up with something that's a third written with a root 3 in it. Do yourself a favour, keep it as a third, unless the question specifically asks for it. Chances are it won't. Now that I've got my a, I can just use the standard form here. The only thing I have to remember is I've got a half here multiplying the integral. So I'm going to get a half times the solution here, which is then given by sine minus 1 of x divided by a, so x over root 3 over 2 plus a c. So if we sort what's in here, what I'll end up with is a half sine minus 1 of 2x over root 3, close the bracket, plus c. So there we go, we've integrated that one there. The only extra step is getting rid of this coefficient of the x squared there, so that we end up with it in the right format of a squared minus x squared, not minus something times x squared. Just remember that to begin with. Third and final one was a definite integral, so the integral from 1.5 to 3 of 1 over 2 plus x squared dx. Now this one is remembering another standard form we have. So the integral of 1 over a squared plus x squared dx, we know that that's given by 1 over a tan minus 1 of x over a plus c. Now the plus c comes with an indefinite integral. Here we've got limits, it's a definite integral, so we can just exclude the plus c when we do it. Again, it's equating over and making sure we get the a's and the appropriate parts together. So in this one, if I look it over, a squared is equal to 2, so my a is equal to root 2. So then I can use this to integrate, so what I know then is my integral 1.5 to 3 of 1 over 2 plus x squared dx. That can be written, put in a square bracket, of 1 over a, so 1 over root 2 times tan minus 1 of x over a, so x over root 2. And again, we don't worry about the plus c because we've got the limits, 1.25 and 3. Now just like a normal integration at this point, we do top limit, take away the bottom limit, and we get a solution from that. So what this is going to give me is 1 over root 2 times tan minus 1 of 3 over root 2, take away 1 over root 2 times tan minus 1 of 1.5 over root 2, close that bracket as well. So upper limit, take away the lower limit, and at this point I can just fire it all into a calculator. Firing it into a calculator, I get 12.7805, and it continues on. Let's round it to one decimal place here. We get 12.8 as my solution. So there we go, 3 different examples of it. The key thing is remembering those standard forms we went over of the integral of 1 over square root of a squared minus x squared and the 1 over a squared plus x squared. Remember those and it makes your life a heck of a lot easier, and the only extension from that really is if we have limits, just remembering what we do with limits whenever we do any integration, substitute them in and do upper limit, take away the lower limit, job done.